Welcome everyone to this lecture, and welcome to the lecture 5. So in this lecture 5, we actually gonna discuss about assignment 4. Yeah, you are hearing correctly. We are discussing about assignment 4 in lecture 5. So in assignment 4, you have problem 1 and problem 5. So we're gonna to get all the information of patient MRI image. This is very important because you will need it for your research soon. So I made this video to give you a tutorial in detail how to work with 5 in your data, in your patient data, in your real patient data, and using Python RadarMesh to extract the RadarMesh feature. So I hope that all of you will look at this video carefully. So before we move on in the solution, let's discuss about PyPy project first. So here we have a PyPy project. So PyPy project is a project, an open project that contains all information of the most popular Python library, Python modular. So usually every Python modular have a document in PyPy website, so you can get it. So for example, when you do a research about RadarMesh, you need a PyPy a Python RadarMesh module. So we usually call that PyRadarMesh, and if you want to, you need to install PyRadarMesh to your Python, because Python doesn't build in PyRadarMesh modular. So you need to install from a third party. It means that you need to get it from another team, not the official Python team. Another team we call it PyRadarMesh team, and install PyRadarMesh modular into your own Python. So how you can do that? So you need to search PyRadarMesh PyPy and go to a link here. So and you will get a statement like that. So move on, and if you are using Python 3, so try to type in pip 3 install the modular name and hit enter. So that's it, because I'm already installed by RadarMesh, so it will notify that I am the requirement already satisfied. It means that I am already installed by RadarMesh, so we have everything ready now for us to move on. So before we extract the RadarMesh feature, because RadarMesh feature needs two things. The first thing, we need image here, NRD file, and the second thing we need is a mask file. It's also NRD file. So in the real data, we may have 100 patients or more than 100 patients, so we cannot try to extract the feature of patient one by one. We cannot do that. We cannot spend a lot of time to do it manually. You should think a way to do it automatically. Okay. So before we try to extract a feature, we need to get all the image file and mask file of patient. So how can we do that now? The first step here, we need data D. So we need a data D here. Sorry, we can type that. So first step here, we need a data D. So where data D now? So you should know that in here it is our source code. In our source code, we have a src directory, a folder, And inside src folder, we have a lecture 5 here folder, lecture 5 folder here. So we are staying here. So it means that if you want to get the data, you need to go out one step to reach the src folder. And when you move out another folder, you will inside csc our one folder here. So here data here. So if you move on one step here, you will see you can see lecture inside src folder. And if you want move on one step here, you will get the csc our one folder. And in here you can get inside the data folder here. And inside the data folder you have a DICOMS folder. So DICOM folder here. So that's your data D. So it means that you can access to all patient data if you stay there, stay in DICOM folder. So we good. Okay. And in here we need to load all patient data here. So you need a Python module we call OS module. So try to import OS module here. Yeah, that's it. All right. So we need to load. So we need to define a function. We call it load patient info. Yeah. So you can say the function name is load patient data, patient files, everything you want. So I just name patient info. So here I input the patient data here, so that, and I try to load the data. So first step we need what? You will need a function. It's called list here. OS list here data. What's list here? The list here will try to give you all the name of all the files and folder inside DICOM folder. Yeah, that's it. I will show you example. So we stay there, and we need OS modular. So we need the data D here. And we need list D function. If you input data D, so you will see that that's on the folder name inside a DICOM folder. But if you have a file, maybe image file inside DICOM folder, it also appear here. But in this case, we only have a folder names inside DICOM folder, so only folder name here. So that's it. So the next, we need to go inside every folder here, every subfolder here, sub-patient folder to get the data. So we need to keep move on. So keep in mind that we need to go inside every folder of DICOM folder. So we need to use for loop. We have no choice here. So can we try that? Okay. And go inside. So similarly, we repeat this step again. Try to get list here. But keep in mind that when you have a sub D here, it's just a file name. It's not exactly the map to travel inside a file. So for example, if you just type OS list here and input the folder name, they will notify error. Why this happened? Because when you try to run in the Python here, I'm trying to run in the Python in here, in the lecture file folder. It means that in here. So and the data this folder is belong to this DICOM folder, so they are not in the same location. The location I run in Python it means that the location I'm trying to run a Python shortcode to show you a demo here, and the location of this folder, they are not the same, they are different. So when you input just the folder name here, the Python code only look at the current location where it's running now, and if they don't see this folder, they will notify that there are no such file or directory here. So if you want to access the data here, you need to give a map or direction to Python to let the Python know that you need to move on to this directory and go inside this directory later. Then okay, so how can you do that? You can use the modular. We cannot always pass short here and try to give data here and the folder name. This is folder name. So if you have a sub there, okay, so you have a list there now. So we good. You see that inside this folder, inside 7128128. Yeah, that's it. We got it. See, right? So you got it. So in here, we need we can say that it is the path here, and we use the modular path chon sub dir. That's it. And here we say sub dir path. So in the next line, what we need to do similarly, because we need to, because inside each patient folder we have a subtraction and T2 folder, so we need to move on. We need to move on more sub D here. Okay, so we need something to store patient information, so we can use patient data, and we should use a dictionary. It's very convenient for this case. So, and we move on for sub D here. Okay, we need to go inside this folder again. One more step to go inside. So I hope that you do not confuse it. So we have a sub D here. Okay, and we need to list there. And similarly, we need to use we can say that it is sub dir path here. Yeah, and you sub dir path. Yeah, and sub dir. Yeah, that's it. I hope that we good now. All right, keep move on, and that's it. So until now here you have a subtraction and T2. So try to move on. Sub D again. Yeah. Okay, and inside, for example, inside subtraction folder, we have many files here. So we only focus on NRD file and ignore the rest one. So if you want to get only NRD file, you need a module we call glob. Okay. So we can say a file name here. We say that is a file name is a glob here, and we need what? We need here, we need here, we need to combine or link together to get a final file path name. And because we only want to use NRD file, so using that's why, and you see that your code is longer than 80 character, including space. You see that I have ruler here. It means that you exist 80 characters, so try to use one more lines for your code, because we don't want the code is very long. It's really hard for reading. It's not human. It's not readable for human. So we need to keep the code, a single code line, not too long. So just 80 characters is good. So we have an ONRD file name out here. So but we need to know where the segmentation and where the file image file. So we need that. We need to know that. But how can we know that? It's very easy one. So so we say there we need to function to recognize that a file name is and segmentation mask file or image file. So we go for the mask file name. We need a function, so we can try to pass mask file name here. Yeah, that's it. And we try to recognize that. So because you see that the segmentation file name will have a segmentation in the file name. Yeah, so we try to get a segmentation file, because the idea of the file is very long. For example, here you see that it's quite long and contain many segments. So we try to get the base name here, because that's the base name. It means that the short name including extension. So we need to get a base name here. So it means that we only get the name segmentation seg NRD file here. So if we have a segmentation in the base name lower, so we will return true. Okay, or you can say that you can try to return, try to use it that way, it's more clearly. So try to return segmentation lower. So if we have a word segmentation inside the base name, they will return true, otherwise they will return 4. Okay, so that's it. So we try to use for loop here in file name. So if mask file name there, file name is mask file, so we will get a data. We get a data, so we need to save in the data. We need to save data. So we need a patient ID. Patient ID also a subdir, here. Subdir means that this folder, because the patient they have maybe it's the tumor patient data. So we need to keep track of patient ID and also the tumor ID. So the first number is the tumor ID, and the second segment is the patient ID. So try to keep both tumor ID and patient ID. So try to use this sub ID, subdir. So subdir. Yeah, that's it. And we need file name here, mask file. So that's it. We need mask file, and we need we can say that is file name because it's a mask file. Okay, but if if that is only true if you if this dictionary didn't have this key yet. So if this key already appear in this dictionary and you try to do that this way, the dictionary will think that you try to update the existing key, and they will try to duplicate, so they will replace the current data of this key. So we need to check that. So if the key not in Bayesian data, okay, not in the Bayesian data here, and we try to, so if we write y, so otherwise if they are not, it means that if the key already exists, so we try to use this way. Here, that's it. So we can say that is a mask file is the file name. Yeah, that's it. Okay, all right. That is simple way. Yeah. So if a file name is not a mask file, so what's gonna happen? So we also need to the same thing. We need to check that if a sub dir not appear in the Bayesian data. So we need to use Bayesian data sub dir, but it's not a mask file, it's image file. So we say that it's image file. If file name, yeah, and L. So we say that we have duplicate code here, so but not much. So I think it's still okay. All right, we can copy here for shorter, for saving time, and we say that image file. Yeah, that's it. So we good now. So we hope that we still good. And after because this Bayesian data is global, we can label real, but I think we don't need that. We just need to react here and try to return. Okay, so I'm trying to resolve the assignment 4 with a function. So you can do it without function, but with function is more better. Okay, so we need here. That's it. We need the data there. So copy here. Oh, sorry. Okay, that's it. We need this function, load Bayesian data. So we can create data because they return, so we need something to get back. So data dir, that's it. We good now. Okay, so try to print out what Bayesian data we get. Yeah. Okay, so try to use that's why Python 3 Radamix tutorial, and we see we get error. You see that they show that you get error, wrong syntax, invalid syntax in line 11. So go to line 11. So remove this one, and that's it. We got data. So, but you see that it's not readable to human. It's quite complicated and massive. So we can try to format it so it will be more readable to human. So you need all module we call import OS. Import JSON. We need JSON. JSON is one kind of format data. So here we can try to JSON to DOM async string here, and try to put some indent. We call it indent 4 equal to 4. So that's it. So to run again. So you see that it's more beautiful, and we got all the data here. So it's ready for extract random mix feature, and we implement a function we call that extract random mix feature. Here, and we need Bayesian data for extract random mix feature. Yeah, but how can we extract random mix feature? We need some code. Actually, they are all the same for all Bayesian, so you can try to copy. You can copy from my code. It's for saving time. Here, you need a module. This modular is from the Python random mix, so you will need it, and you need a parameter file. So I will check it. Sorry, I will explain it later. So you don't need to focus on that right now. Okay, so you can put it here in the main function. Yeah, and you need instructor, a random instructor. That's how can we initialize. Yeah, that's it. So we good now. So we need a feature. We need a feature instructor now. So we try to use it for extract a random mix feature. So I think we should move these two lines of code to this function, because we extract random mix feature inside this function. So okay, good. So we need to move on all the Bayesian data. So try to move on. So we need Bayesian ID here and value. Try to in Bayesian data item. That's it. We have a key and value. The key Bayesian ID in the value it contain image file and mask file. You see that? So we need image file here. Image file is the value image file, and we need a mask file is value mask file there. Okay, so we need a feature extractor. So you see that I provide example here. So you need that this way. Just copy it for saving time. And then we return you random mix feature. Yeah. So we can you can try to store the data inside a dictionary, but you can try to update the current Bayesian data dictionary. So try to use Bayesian data. We call that Bayesian ID here, and with a new key we call random mix there, and it's equal to random mix feature, and that's it. And keep in mind that the Bayesian data here is a mutable data, so when you use this way they will directly update the Bayesian data dictionary. So it means that the Bayesian data dictionary already updated. So that's it. We try to call a function. We try to call this function and give them the Bayesian data there, and try to read out the new result. I hope that we can do that. And here get result. They are extracting the random mix feature. You see that they are quite so slow. So You see that you will got the error in the curve line here. Last city, it means that's there because the random image feature is not JSONable, so you cannot try to output a JSON. So we need to debug in. You need to debug so to see how can we resolve the problem. So try to run it again. And there, we've been here. So we need to check the data type of the random image feature. See that? It's the older dictionary. So how can we try to convert it to dictionary? So random image feature. The older dictionary is quite very special dictionary, so we cannot use it for JSON. We need to convert it to original dictionary. So try to use it that way. Yeah. So what you see that here, array is here. It's not a single number. It's a very complicated data type. We call it a number array. So you will know it later. We cannot try to extract it here to JSON because it's quite complicated. And in the next lecture, when you learn about OOP and another maintenance, I will give you more explanation how do you try to resolve that problem, to try to write out the data into a file for saving for another purpose. Okay, so I will upload your code to GitHub and you can look at the data. You get a code in the GitHub. Okay, so goodbye and see you in the next lecture later. See you.